you just switch on the camera on? Yeah, now you can introduce. So
Hello, am I audible?
So I'm pleased to introduce our second speaker for the day 2. He is Dr. Sachin Sharad Pawar, sir. He is currently working as scientist in TCS Research Pune since September 2010. His areas of research includes natural language processing, text mining, data mining, and their applications to various domains such as human resource analytics, legal analytics, information and knowledge extraction from domain-specific documents. He has published around 40 papers in national and international conferences and journals, as well as holds 10 plus patents in the area of natural language processing and its applications. We are honored to have you over here, sir, and we are looking forward to your session. Now I request Dr. Sachin, sir, to take over the session.
Okay, thank you for the kind introduction and good morning all the attendees. So I'll share my screen, just confirm if it is visible.
Yes, sir, we can see your slides, sir.
Okay, yeah, thank you. So yeah, again, good morning everyone. So today I'm going to talk about our work in information and knowledge extraction from resumes and its application. So this is one of our major works in the HR analytics area. So the outline of the talk is going to be, I'll first talk about Rings, which is our information extraction engine to extract information from resumes and store it in structured format. So Rings stands for Resume Information Extractor. So for half of the time I'll spend in explaining this. And then there are two applications, one of which I'll go into detail, which is the recent one, which was published in PAKDT 2022. Which is on predicting skill proficiencies directly from resumes. And another application I'll just touch upon because I think we'll be short of time by then. So which will be automatic shortlisting of candidates for recruitment. So again, this was work which was published in Profess Workshop at SIGAR 2018. So given this outline, now I'll begin with first information extraction from resumes. So what is motivation behind this? So first is, as you all of you know, resumes contain a lot of details about everyone or about the candidate, like personal details, education details, work history, skills, roles, projects, various training, certification, and so on. So all these details are present in unstructured form. And like big organizations like TCS, they receive large volumes of such resumes. And these unstructured resumes are impossible to like mine or search or to gain some insights from. So that's why it is necessary to convert them to some structured form so that lots of analysis can be done on top of it. And what kind of analysis may be required? So for example, the recruitment executives, so they perform various tasks on this repository, like making queries on resume contents. So for example, find me candidates who have worked in Java for at least 3 years, or creating a rank list of candidates, short list of candidates for a particular job requirement, or finding experts in a particular area. Let's say I want someone who is a expert in database restructuring, for example, understanding various wider trends or skills, how they are changing in job market. So for example, if you say resumes 10 years back, so the dominant skills were Java related skills, but now if you see the recent ones, so they are now in various different domains, like Python has now kind of replaced Java as a dominant language and so on. So all such trends can be analyzed. So for all this, we have this tool called Rings, which extracts this kind of structured information from unstructured resumes. So there are lots of challenges in designing this system. So first is there is a lot of variation in the structure and contents and styles of the resumes, and it varies from person to person. Also, the variation is observed across functional areas, like a HR person writes his resume in a different way than a finance person or than an engineering person. Or also this is observed across, the variation is observed across industry domains. So like a banking or finance domain person's resume will be much different than a IT person's resume and so on. So, and the structures and contents or styles also keep evolving over time. So all these are the challenges that we had in our mind to build such a system. So before going in detail of the resume information extractor, I'll quickly cover some basics of information extraction. I think some people in audience may not be aware of the details. So what is first information extraction? So information extraction at a high level is extracting some structured information from unstructured natural language text. So generally, this information we try to, or the most basic elements are in the form of entities and relations. So in entities and relations, what are these? So first of all, an entity type can be defined as any object or a set of objects in real world. So for example, a person, a organization, location, these can be entity types. And entity mention. So this terminology is used for specific instances of these entity types. So for example, if person is an entity type, then Sachin Tendulkar is a entity mention or a mention of that type. Similarly, University of Pune will be mention of organization type and so on. So this distinction is important between entity type and entity mention. So entity mentions are those phrases which are actually realized or actually written in text, and entity type is their type of the named entity or type of the entity which that particular phrase belongs to in the real world. Similarly, when you come to resume domain or any domain specific things, you will have to define domain specific entity types. So in resumes, we have defined entity types like employer name or the past employer names, degree name, institute, designation, skills, and so on. So examples of these entity types can be, you can see here, like ICICI Bank can be a past employer, BTech can be a degree, University of Pune can be an institute, and so on. So yeah, these are again some detailed entity types and their mentions. So for example, you can see names, email, date of birth, all personal kind of details, or employer designation. So designation is senior customer care representative. So these are specific to the resume details and so on. So this is how we have defined all these entity types, and we have developed this system which extracts these entity types using various methods. Now coming to relations. So generally in general domain in NLP or information extraction, you do not stop at just entity extraction, because that is kind of every entity type is treated or extracted independently. Whereas if you see in real life, all these entity types are actually connected to each other with various important semantic relationships. So if you consider general entity types like person and location, so multiple relations can exist between mentions of those types. So one of that can be born in relation. So born in will indicate the person is born in at a particular location. So for example, when I say born in Barack Obama, Hawaii, we know that Barack Obama is a mention of type person. Hawaii is a mention of type location, and Barack Obama was born in Hawaii. So this relation holds between these two entity mentions. So it's analogous to entity type and entity mention. We have here relation type and relation mention. So born in is relation type, and born in and a specific combination of entity mentions, that is in this case Barack Obama and Hawaii, makes a relation mention. So as we had domain specific or resume specific entity types, here we have resume specific relation types. So like career is one relation that we define. So this relation exists between entity mentions of type, employer, duration, and designation. And it has a certain semantics associated with it, because what it says, any employer mention, the person had worked at that particular employer for this particular duration and as this particular designation. So that completes or that builds on the that builds a higher level meaning on top of simple employer, duration, designation entities which are extracted. So it binds together some of those entities, and we call that as a career relation. So you can see your example of a career relation mention can be ICICI Bank, July 2012 to September 2015, relationship manager. So here, the semantics behind it is the person whose resume it is. He has worked in ICICI Bank as an employer for the duration July 2012 to September 2015, and as a designation or holding the designation, a relationship manager. Similarly, another relation that we define is education. So which is, so like career was a kind of three arity relation. There were three entity types involved. Education is a four arity relation. So where there are four different entity types are involved, that is degree, marks, institute, and year of passing. So it also completely captures information about a particular education record of a person. So like what was the degree, what were the marks in that degree, from which institute that degree was obtained, and what was the year of passing. So for example, degree can be BE, that is Bachelor of Engineering. The corresponding marks were 77%, corresponding university or institute was University of Pune, and year of passing was 2012. So this is how we have defined certain relation types, and these are examples of the corresponding relation mentions. And now we'll see in brief how we actually extract this. So coming to extraction of entities, so first of all, as I have already said, we extract various types of entity types like name, email, and so on. These are personal kind of details, or employer designation, duration. These are employment kind or past work history kind of details. Degree, marks, institute, year of passing are education related details. And also specifically in terms of technology people or IT people, there are lots of project details which are available. Like, so what is a project title, role in that project, skills and tasks used in that project. The client specific, if there it is project is for a specific client, then client also becomes one entity type. So all these entity types we try to extract. And there are various entity extraction techniques, because in real life, what happens if you only depend on one technique, you won't get, or you won't get a desirable performance or a reasonable performance. So what we do is we depend on multiple techniques. So first is supervised kind of techniques. So these are techniques based on CRF, LSTM, CRF, but these are supervised. So this needs some kind of annotated data or annotated resumes for training. But these are very easy to extend for new entity types, because you don't have to code any new component. You already have a component. You just provide some new annotations and for a new type, and then you have a ready-made system which can extract that type. Also, there is one very simple approach which works quite well in practice for some entity types, is gadget based. So gadget is nothing but a set of or a list of entity mentions which you already know belong to a certain type. So for example, degrees. So if you see in India, if you list down, let's say frequent 100 degrees, which people can get, like Bachelor of Engineering, Bachelor of Science, Master of Technology, and so on, then like almost 80% resumes, you will find those degrees. So it's simply looking up in that known list and identifying that particular phrase as a degree. So this is a very simple gadget-based approach. We also have some approach where we create these gadgets semi-automatically. Then there is a pattern-based approach, which is also very strong. So these are kind of regular expression-based patterns, which we fire or which we match against enriched text format. So what is enriched text format? It actually a simple text is enriched by adding various linguistic information like part of speech tags or parsing information, dependency parsing information, and so that the regular expression patterns become quite robust, and they also become linguistically informed. So, but these, so the one advantage here is you don't need any annotations. You don't need any annotated data. You can simply write patterns, and so it's kind of it's not a supervised technique, but it needs human expertise in writing these patterns. And finally, we consider ensemble of all these approaches, so which works better than each of these. Similarly, coming to relations, primarily we identify three relations: career and education. I have already explained. The third relation is project relation, which is mostly specific to IT people or the information technology candidates. So here again, we have two methods. One is supervised method, so which is based on a sequence autoencoder and LSTM CRF. So I'll give you a brief idea about this in one of the later slides. It also needs resumes for training, annotated resumes for training, but it is easy to extendable to new types in future. We also have a rule-based technique, so which uses the entity extraction output and writes a very set of very simple rules but high precision rules. So for example, in a resume, in a single line, if you find a degree name and you also find, let's say, marks in the same line, you find year in the same line, then you can easily say that they all belong to the same relation mentioned and you combine them together. So, and this is the one of the simplest rule that I said, but there are some 3-4 such rules which are coded, which are very high precision. That means whenever they work, they are very good. they do not need any training data as such, but they may miss some kind of mentions, or in some kind of resumes which are written in very different style, they may miss that. Whereas supervised is much better in that kind of generalization. So that's why we use again both of these, and we finally take ensemble. So now I'll quickly show you some examples how this works. So this is a resume snapshot in this red box, and the output, structured output that we extract. So structured output can be in any form. So currently we extract it as a tab separated form. So where there is an entity type, you can see name, then there is a tab, and then there is actually mention of that type. Similarly, in XML format, where the tags are defined, XML tags are defined in such a way that the values are entity mentions and the tags correspond to the entity types. So this is example of personal detail. Then this is another example of work experience detail. So you can see again a resume snapshot in a red box, and you can see the corresponding XML output here. So here it has already detected Artec Industries as an employer, then March 2005 to July 2006 as the corresponding duration, and senior customer care representative as the corresponding designation. And similarly, corresponding TSV output looks like this. Here, just that every column has to have semantics, like first column is employer, second column is duration, and so on. This is example of extraction from education part or education details part. You can see here now this person has written it in a table. So tables also we convert in kind of rows, and the cells we maintain some kind of cell separators so that we are able to process this kind of information. So here also you can see degree is identified as bachelor's degree. Then the Government College of Engineering Aurangabad is identified as institute. And then the marks are not there, so marks will be NA. So this is another thing, that these relations are actually partial relations. Not all information will be available in all resumes. Like in this resume, marks are not given, so you need not check for marks. Or worse, you should not assign any number which is nearby and treat those as marks. So this is also identifying marks as NA is also important thing here. And finally, this is example of certain project kind of experience. This is generally found in people from IT domain. So like they work for a particular client for a particular duration. There will be some name of the project, role of that person in that project. So here you can see it's a support software developer, or some details about roles and responsibilities in the project. So we extract all these as skills like Java 7, Spring MVC, and so on. So here you can see these are the corresponding structured output. You can see client is identified as jet privilege, duration of the project is identified, list of skills are identified, XML, JSP, and so on. Tasks which are done are identified, like developing various reports, involved in support activity, and so on. So this was a very quick overview of resumes and what different things that we extract from resumes. So this is summarizing. This is the overall architecture. You can see the input is resumes in either PDF, doc, text format. So which look like this. We pre-process them. First step is PDF, doc to text conversion, then NLP pre-processing, ETF generation. Here we also use gadgets which are known. Then these pre-processed resumes are obtained here in the enriched text format. Entity extraction happens in 3 parallel ways: linguistic patterns, CRF-based extractor, LSTM CRF-based extractor. There is ensemble of these techniques and you get extracted entity mentions. Now relation extraction works directly on the resumes as well as on the extracted entities. It also has supervised methods, rule-based methods. It makes an ensemble of both the outputs. Finally, there is some post-processing of the extracted output, and we get this final structured output, which is in XML or TSV format. So this is the overall flow of rings. Now I'll quickly give some details in brief because it's not possible to cover all the details. But let's say I'll give you quick examples of how linguistic patterns look, how a deep learning model is there. So this is a very simple example of some linguistic patterns, so which are very high precision. So that means whenever they are matched, you get a output with very high precision, but they are not high recall because you cannot think of all possible ways a person may write some entity dimension. So here you can imagine there are 2 patterns. First pattern extracts any noun phrase as an employer if it is connected to a verb like work, working, employed through prepositions with, in, and at. So any noun phrase which is connected or which is a child of a verb, which is either worked, working, or employed, and the connecting prepositions are with, in, or at, then that noun phrase is identified as an employer. Similarly, any noun phrase which is connected to the same set of verbs but with preposition as is identified as designation. And you can see there are this pattern is applied at various multiple things in resumes, and these are from various different resumes. Like I am presently working at Muthoot Finance Limited. So now this gets identified as employer, as accounts assistant come branch in charge. So this gets identified as designation. Similarly, currently working with United Health Group as team manager or working. Now this order is also not important because we are looking at a dependency tree. So here you can see designation comes first, but still the same patterns will work. Like because working as a branch manager in SKS Swarna Purushpam Gold Loans. So this gets identified, the red phrase gets identified as employer. The blue ones gets identified as a designation. So this is how, and these are just some examples. Like that, there are more than 40-50 rules which are written by observing lots of resumes, and they work quite reasonably well in terms of precision. Recall they may miss something. That's why the supervised techniques help in terms of generalizing and giving the recall. So now deep learning model, this is one example of LSTM CRF model that we use. So here you can see the the words are fed in this LSTM model, currently working at United Health Group. So this is one time step, one word is fed like normal LSTM usage. This is a bidirectional LSTM. And we use finally for decoding, we use CRF, and this is a MLP, that is a simple dense or linear layer. And at each word we predict a label which is in terms of an entity type. And this B and I indicates, B indicates beginning of certain entity type. So here B beginning of an employer name, inside employer name, and O indicates outside any particular entity type. So this is a standard BIO labeling in named entity recognition, which is a standard recognized problem in NLP. So the same models we adopt, but we train it for the specific entity types that we have. For relation extraction, we extend the same model. You can see that it's like a hierarchical LSTM model where the horizontal LSTM you can see is the same one that we saw on the previous slide. So which works at a word level or at a sentence level, and at each word it predicts some label so that we get entity mentions. And there is a vertical LSTM also by LSTM CRF. So that's why it's a hierarchical LSTM, because the horizontal LSTM representation is fed into the vertical LSTM, and vertical LSTM is kind of a sequence over all sentences. And the horizontal LSTM works over sequence of words over a particular sentence. And like that, it works for all sentences. So these are some snapshot of sentences. So these sentences are individually fed in the horizontal LSTM. So you get a representation for each sentence that is given by horizontal by LSTM. We also consider a vector representation of presence of internal entity types in that particular sentence. And then for each sentence, we predict a label, which is a relation label. So now let's say you see here for this sentence, there is a begin education. That means education relation starts from this sentence and next is O only. So that means the relation ends at this sentence. So all the possible information for a education record is present here. Like you can see PG, DBM degree is present. Another degree name is present, which is the same name. The University of Pune is present and year of passing is present. Similarly, another case, one education record is written over 4 lines or 5 lines. So there the first one gets begin education, which is MCA. Then next one is institute, which is IGNOU. Passing year is December 2004. Percentage is 61.72. So this is for the same particular education record. So this everything will be combined in a single relation, and this tuple will be formed. Similarly, another relation type is career. So here you can see this is some GXX Infotech is an employer name. Then some address of that is given. Then the duration is given. Some description is given, followed by a designation. So all these three. So GXX Infotech, this particular October 2011 to Jan 2014, and the designation will be captured in a single tuple. So this is how our relations are also identified. Yeah, so that was a very a quick details about the rings information extractor. So for each of these, we have different papers. So for details, you may look at those papers. But this was like these slides will cover a very high level overview of relation extraction. Resume information extraction. So now we will go to the application. So where I'll cover one application in detail. So which is a skill proficiency estimation from resumes. So this was a paper which was recently accepted in this year's PAKDD conference. Yeah. So coming to motivation. So why we need to estimate the skill proficiency? So first, in many practical situations, so you may come across a need to estimate proficiencies for a person given his or her resume. Because suppose there are interviewers who want to interview that person, they quickly want to see the resume and see what are the major skills in which the candidate has some expertise and assess some level. Like in Python, he is intermediate. In machine learning, he has a very basic knowledge and so on. But in Java, he has an expert level knowledge. So the questions can be asked accordingly. Also, in a large organization, you can use this to assign employees to a project. Suppose a new project comes up, it has certain skill requirements, and you have a certain employees in your pool. They also have certain skill profiles. So if you can estimate their skills and proficiencies in his skill, you can form together a group and you can assign that group for a project. And again, for a particular job position, you may want to rank the candidates and so on. So there you may have to not only identify skills, but you also predict the proficiency level in the skill. So till now, what we saw only extraction. So what rings will do is it will only identify skills which are mentioned in the resume, but it won't judge any proficiency in that. So it will simply extract and keep it in some database. So this is the next step where we use that extracted information. We study the resume, other features in that resume, in what context the skill was used and so on. And we predict proficiency level. So goal here is to automatically and quantitatively estimate proficiency of a person in a given skill based on her resume RC. Why quantitatively is important? Because it may be a very subjective opinion. So suppose if 3 different recruitment persons see the same resume, they may end up at different estimates. So it is good to have one kind of objective kind of assessment. So that's why this is one of the options. And the proficiency level of a person in a skill is measured as a numerical score. So that measures the knowledge, understanding, expertise, and ability to apply that skill in practice. So I'll cover some scope and assumptions that we had for this problem. So first of all, what we call as a skill. So skill we generally call as a broad technical subject or area of knowledge. So like databases, Java, machine learning. So each one of these we call as skills. A skill may include many skill markers. So skill markers can be sub-skills, it can be tools, can be concepts which are dependent or which are related to the skill. So for example, the higher level skill machine learning may include reinforcement learning or deep learning as sub-skills. Weka, TensorFlow, PyTorch, all these as tools, or regression, decision trees, all these as concepts. So all these skill markers. So machine learning may not be explicitly written in some resume, but the person may have written some project where he has used decision trees, or he has mentioned that he knows Weka, he knows TensorFlow, or he knows deep learning and so on. So from those skill markers, we need to map to a higher level skill. So that is the first step. And for mapping these skill markers to skills, we extensively use DBpedia, and we created list of all such skill markers which can be mapped to a particular skill. So for example, J2E can be mapped to Java, SQL can be mapped to database. Some of the skill markers may be mapped to both, like JDBC may be mapped to Java and database both. So one skill marker may be part of multiple skills also. And as I said, our resume may not explicitly mention a skill, but there may be many relevant or related skill markers mentioned in the resume. So we use all that information and then we collate all this at a skill level. And some assumptions we had to make to simplify the problem. So first is proficiencies in multiple skills mentioned in the resume are estimated independently of each other. So like I independently measure proficiency in machine learning, independently measure proficiency in Python, which may not be necessarily true because a person who is quite an expert in machine learning is highly likely that he also knows some expertise in Python. Also, all the skill markers are assumed to be at same level of abstraction. So, but some of these may be, for example, reinforcement learning may be a very deep area in itself, whereas decision trees is a very small concept, and but still we treat all these at a same level. So these are some assumptions that we make. Now coming to problem definition. So we have this resume information model, which we saw, which is nothing but the structured information that we get for rings. So for skills particularly, we focus on two areas or two types of output that rings extracts. So first is project information, which covers duration of the project, roles performed in the project, skills and tasks carried out in the project, as well as some certifications and courses information that people write. So these two things we focus on. So this is one example from a certain resume after extraction. So there are 3 projects this person has done. So first project duration is 24 months. So this duration we compute from the, let's say someone has written January 2022, January 2021. So we automatically compute duration as 12 months. Then there are skill markers which are present, like Java, Struts, J2E, Tomcat, and so on. Roles which are being performed, backend developer and web developer, and some important tasks which are done as part of this project, like system architecture design, design data models. And likewise, the person has done 3 projects. Second one is also a 2-year project, 24 months. Third one is a 5.5 months project. So this is kind of an example of extracted output. From that, we use this as a input. And what we do is we define a feature vector for each skill and a resume. So for a particular resume and a particular skill combination, like for example, a person X and skill machine learning, this combination, we create a feature vector of 8 dimensions. So what are these 8 dimensions? So first is total duration of all projects related to skill S. The second is number of projects related to skill S. Third is number of distinct roles that the person has performed in the projects which are related to skill S. Number of distinct skill markers or different skill markers related to skill S mentioned within the projects. Number of distinct tasks mentioned within the projects related to the skill. The next 6 checks the focus that the person has on that particular skill. So this is the ratio of X4. This is number of distinct skill markers related to skill S to the total number of skill markers. So some person may have different skill markers, but let's say now you are estimating for machine learning. So only few of them are related to machine learning. So that focus on machine learning is less. So his X6 will be lower. Similarly, X7 and X8 come from the number of certifications and courses or number of distinct skill markers mentioned anywhere in the project resume, not necessarily within projects. So X8 is always higher than X4. And this is again a kind of a sample from the previous example that I showed here. So for that, this vector looks like this. 53.5 is a total duration. Then 3 is total number of projects and so on. So I'll show you in this form. Yeah. So here you can see this is a sample input, which is a rings extraction output. And these are the features which I explained on earlier slide, X1 to X8. And these are the corresponding value. So for example, X1 is total duration of all projects. So this is 24 plus 24 plus 5.5, which is 53.5. The number of projects is 3. Number of distinct roles is these 2, backend developer and web developer. So 2 distinct roles. Number of distinct skill markers is 15 and so on. So this is how all these features are calculated. And now coming back to the final goal in our problem definition. So it's to learn a skill proficiency function, which maps any such feature vector from 8-dimensional space to one of the 5 proficiency levels. So from E0 to E4, that is E0 is the lowest proficiency, then E1, E2, E3, and E4 is the highest proficiency level. So this kind of function we have to learn. So for example, for Java, this given this resume and this feature vector representation, proficiency level is E2. So this is one example, and this is how we want to learn this function so that given any such feature, or given any resume, we can compute this feature vector and predict the proficiency level. So that is how we define this problem. So this we have already covered. Yeah. So now coming to techniques. So firstly, we looked at the literature and we saw what are some techniques which are already existing, which we can look at as our baselines. So the first one we tried was ordinal regression clustering. So this is it's from Horesh et al. It was published in IEEE International Conference on Big Data 2016. So this one was interesting because usually if you do clusters, there is no natural ordering among the clusters. Because especially in n-dimensional space. So but this particular approach was giving natural ordering. What it was doing is something similar to SVM, but in SVM there is just one hyperplane. Here, if you want 5 different categories or levels, you get 5 parallel hyperplanes. And in a very similar kind of optimization framework as SVM, they were learning this kind of multiple parallel hyperplanes. And we used that directly and we got 5 different levels. So we ran this for 5 different levels because we expected 5 levels and we saw how it works. So advantage here is it's completely unsupervised. You don't need any supervision, but the performance was not so great. So we'll see the output. The second one was a supervised method, which was based on this ranking-based multitask learning of scoring functions in ECML PKDD 2017. So what it was trying to do was learn a linear function where it's a simple linear layer. You can see wi xi plus b and it's passed through a sigmoid. So you get some score between 0 and 1 multiplied by 5. You get some score between 0 and 5. And then you can simply cut at between 0 and 1 is E0, between 1 and 2 is E1 and so on. It was supervised in the sense it required some training data or annotated data where there were pairs of resumes were given and each pair is annotated with a relative proficiency level. So like you will be given annotator will be given a pair of resumes X and Y, and annotator will be asked whether X is better than Y in Java or like in particular skill, let's say in Java, in machine learning and so on. If yes, then 1 will be assigned. If X has lower proficiency than Y, then -1 will be assigned. And if the annotator finds both X and Y are comparable in that particular skill, then 0 will be assigned. So this training data is needed for a particular skill so that different function is learned for a different skill. So this is, but in practice, what we found was this relative label was very interesting because when you give a resume to someone and ask to give a proficiency level, let's say E0, E1, E2, that is the absolute proficiency level, that is generally found very difficult by the annotators. Whereas if you show them a pair of resumes and ask who is better, then it is generally much simpler. So it was actually quite fast to collect this kind of data. And there were 2 loss functions that were used. So first was for a pair of resumes X and Y. Let's say the label indicates that X has a better proficiency than Y. Then f of X should be greater than f of Y by the margin of 1. And if it is not, then some loss will be incurred. Suppose if it is not greater than margin of 1, then you can see it's like a hinge loss function. So you will get a margin loss function. You will incur some loss. Ideally, f of X should be, and if f of X is greater than f of Y more than 1, then you can see there will be a negative number here and 0 loss will be incurred. Otherwise, some positive loss will be incurred. Similarly, if label indicates that X and Y both should be at same level. So this was a new thing that we introduced. In the original paper, it was only 1 and -1 kind of labels. But in practice, we found that in many cases, annotators were confused. They found both the persons at the same level. So we'll introduce this new margin loss where the annotator has said, or the label says X and Y are at same level. But let's say f of X is much greater than f of Y. Then there will be some loss. But if they are within 1, then there will be no loss. And then using these 2 loss functions, we trained this model. That was our B2 model. Then coming to our own techniques. So in B2 also we had our own contribution, but still M1 was a completely new or our technique, which is that because in B2 we observed that it tends to overestimate proficiency levels because it was trained only for relative labels. It works well in relative comparison, but the absolute level that it predicts is generally very much overestimated. So what, because it was not considering some domain knowledge. So what we did was we tried to make it in accordance with TCS definition. There are some proficiency definitions. So we simplified those definitions and we formed certain constraints which generally HR people have in their mind while assigning or deciding these proficiency levels. So these are very examples of some simple constraints. So what this constraint says is X1 is less than 12. That means a person has less than a year of experience in a skill. Then his proficiency level should not go above 1, that is E1. Similarly, if his experience is less than 36, that is 3 years, it should not go above 2. Similarly, 72 for 3 and 120, that is at least someone should have 10 years of experience, then only you can get E4 or E5, that kind of the proficiency level. So these are not hard constraints. We did not want to make them hard constraints. So what we thought of, we include this constraint in terms of a new loss function. So what these constraints do is they define a maximum possible proficiency level for a person. So suppose a person has, let's say 36 months of experience in a certain skill, then his maximum possible proficiency level becomes E1. And then whatever, suppose he is actually getting more than that, then it should incur some loss. So this is the upper bound on X or the maximum possible proficiency, which was identified. And we defined a new loss function, which was this constraints loss function. So for a given pair of X and Y resumes, suppose f of X is becoming more than its upper bound, then it incurred some loss. Otherwise, if f of X is lower than UB of X, there was no loss. And similarly for Y. And because of this, the model also, and the other two loss functions are already there, the loss 1 and loss 2 that we discussed earlier. And we take a linear combination of these two loss functions with the constraints loss function to get a final loss function. And then we also made the model non-linear by adding one more layer. Here you can see there is one more linear layer with ReLU transformation. And finally, we predicted f of X with a sigmoid transformation at a final level. And this particular function was trained for this final loss. So it incorporated both margin loss as well as the constraints loss. So that's why it did relatively also better, and at an absolute prediction also it did better. And in practice, we followed the M1 performed very well, but there was one small problem with M1, which is it requires some manual annotations. That is that those relative labels. Even if those are easier to assign, still it was not possible to scale up at multiple skills. So that's why we developed another technique, which is M2. It was designed to reduce burden of manual annotations. So, and M2 is based on very simple clustering idea. So the given 8-dimensional feature vectors. So there is a 8-dimensional space in which all resumes are mapped for a particular skill. And then we formed some clusters. We used simple k-means clustering and we did 10 clusters. We practically found 10 works quite well. And then a human expert chooses a representative resume from each cluster, and he only observes that cluster and assigns some proficiency level. And that same proficiency level is assumed to be spread towards all resumes in the same cluster. So here the annotation load reduced a lot, because if you have only 10 clusters, the human annotator has to see only 10 resumes and assign some clusters. So that was just part of the training and only annotation effort required. And inference was very easy. Given a new resume, we just find what is the cluster that it is closest to. And that cluster already has certain proficiency level associated. Same level we will assign to that cluster. So here the visualization for a Java, for a particular skill Java, you can see there are various clusters which are mapped. So all these are E0 clusters, which are the lowest level of proficiency. Then E1 cluster is there. E2 is kind of intermediate. E3 is a higher one. E4 is very small because those are always very rare people. So this is what we observed for Java. And this was very easy because only 10 easy from an annotator point of view. Though we don't get as high accuracy as M1, but considering the practical importance of the time and effort needed to create the annotated data, M2 is actually in practice is a very good technique. Now coming to how we evaluated, because this is very important. So we had around 10,000 resumes of IT professionals. So we focused on 5 major skills: Java, Python, database, embedded systems, and machine learning. resumes which have X set equal to 0. That means there are no markers which are present in the resume for that particular skill. They are discarded. So only those people are kept for which at least some skill marker of that one particular skill is mentioned. If there is no marker, then it's E minus 1. That means he doesn't have even have exposure to that particular skill. Then we created two different sets. One is a training set, D train S. So this is created for each skill S. 25 resumes are used and 150 pairs of these 25 resumes are made, and those 150 pairs are labeled manually for relative proficiency level. And also 50 resumes are chosen for every skill, and they are labeled manually for absolute level of proficiency, that is E0, E1 and E2 so on. And these 150 pairs are labeled with that 1, -1 and 0, whether because these are pairs, so first one is better than second, second is better than first, both are equal, these kind of labels. There was some inter-annotator agreement was observed, and obviously it was observed much higher for relative proficiency level. We did some pre-processing, which I won't go into much details now. So like simple pre-processing, like standard scaling up, all making all features mean 0 and standard deviation and 1 of and so on. Now coming to evaluation metrics, this is important. We designed 3 different evaluation metrics. So first one was relative ordering accuracy, which focused on how well that technique is in getting relative order or comparing relatively any two resumes. So this was here we simply compared the class level 1, -1, 0, which was predicted. And we compared that with the relative label which was assigned. So for M1 and B2, 5-fold cross-validation was used because for them you need some training data. And for others, a relative proficiency level is derived from the proficiency level assigned to each resume in a pair. Using that, you can simply create 1, -1, 0, and you check how good any algorithm is on relative ordering on a evaluation set. Similarly, average absolute error, which is let's say predicted proficiency is E2, but the actual proficiency is E3, then you have an absolute error of 1 level. So what was the absolute average of this absolute error by that technique on a evaluation set? And one more was constraints violation factor. So you remember we incorporated a constraints loss, but it was simply a loss function. It did not impose a hard constraint that a person, let's say, has less than 12 years experience, he should get proficiency lower than E1, but he may get higher proficiency. So some constraints are violated. So what fraction of resumes are violating the constraints, the domain constraint? That is another evaluation metric. So now coming to this for all 5 skills, Java, Python, database, embedded systems, and machine learning. These were the 5 skills. And you can see in relative ordering, B2 does quite well. You can see here it is the best method. M1 is second best. But B2 is best, but B2 is not so good on absolute level. You can see it is making almost 2 levels of absolute error. This is what we call as overestimating the proficiency. And it is also violating constraints for 86% of the resumes in evaluation set. So that's why if you see M1 is actually throughout better because in relative ordering, it's almost as good as B2. It is second best here, 58% compared to 63% here. At absolute level, it is giving just 0.6 level difference between two, which is the best among all techniques. Also, consent violation is very low. It's only 27% as compared to 86%. Here, the lower the better. This last metric is lower the better. Second metric is also lower the better. First metric is higher the better because this is accuracy, this is error, and this is consent violation. And M2, you can see M2 is not so good at relative ordering, but it is quite okay or quite comparable with M1 for absolute error. And it has just little bit higher absolute error than M1. And M2 also violates very few constraints. It's actually the best technique in terms of constraints violation. So overall, M1 and M2 both are good. M1 will be preferred if you have certain time and effort to invest for creating annotated data. M2 will be preferred if in practice you want to quickly scale the system for multiple skills. You don't have time and efforts to spend on creating valuation data. So yeah, that was it. So how much time I have? So can organizers tell, or because this was the one that I had to complete in detail. So if you have 5 more minutes, I can quickly give idea about the next application, or we can stop for question answer. So Professor Sachi, how much time do I have?
Dr. Sachin, you can go for 5 to 6 minutes to be here. Am I audible, please?
Hello, am I audible?
I have 5 to 6 minutes, sir. You can go for 5 to 6 minutes.
Uh, hello.
Hello. Hello. How
Yeah.
are you? Yeah, nice to meet you.
You go
Sachin
for
Pawar.
5 to 6
I'm
minutes.
Yeah,
Dr.
hi,
Kuk.
hello.
I'm from Vietnam. Yes.
Oh,
Professor Chung, please
Okay.
wait for your
I
session.
see
I think
some problem you talk
11:30.
about. I think this is a problem very difficult for some a trend digital information. Yes.
Hello.
I think in the future we can contact with you. We share a data set in some field, assemble agriculture and industry and
Hello.
transit. Yes.
Professor Chung. Hello. Am I audible,
So
Professor
okay.
Chung?
I have a question. Please, give me a problem load function. I see you have education load function with load one and load confident. Yeah, please give me. Yeah.
Okay, I did not get your question exactly.
Yeah.
Hello. So are there any other questions?
Doctor, any question from audience side? Any question? Your question. One question you have. Good.
Yes, sir. You listen. I talk about you listen.
No, I was not there for your talk. So did you also give a talk before this?
Okay. Please. I have a question. Please.
Okay. Yeah.
Yes. Please explain. Please explain. Education. Education. A lot function. Yes. I see you. You resent the slide. Education lot function. Please. Diffusion. Yes.
So which slide you have a question? Do you have a question on a particular slide?
Yeah.
Which slide?
Yeah. Come back. Come back. Come back. Yes. Yes. What? Here. Yeah. Yeah.
Yeah.
Yeah. Best. One slide. Best one slide. Yes. This is a log function. You are robust. Yeah. Okay. I see two log function. Log function one and log function
Yeah.
two. But
Yes.
log final and as log function yeah. Really. Yeah.
Yeah. So these loss functions were described here.
Yeah.
These are those margin loss functions. So
Yeah.
those two are used. These are margin losses. And
Yeah.
one more constraint loss is also defined, and both are combined to get the
Yeah.
final loss.
Yeah. Okay, sir. Yeah. Because I have education optimal log function with three log function. Yeah. Okay. Yeah. Okay.
Okay.
Please diffusion log function final.
Yes.
Yeah.
So this is used finally as a total loss final.
Yeah. So I don't see you see a data set in mutilation. I don't see you use a data set.
No, I didn't get your question.
Okay, who has contact number? You can mail ID.
Are you asking about data set?
Okay, no, Dr. Sachin.
Yeah, this is the data set
You
detail.
can further discussion
Yeah.
after the
So
section
for each
over.
skill, there are two data sets, train data set
Yeah.
and eval data set.
Yeah.
So these are created for each of these five: Java, Python, database, embedded systems, and machine learning.
Yeah. Yeah.
Yeah, and using that,
Yeah.
this is reported on those data sets.
Okay. So, yeah. Yeah.
Yes, hello, good morning, sir.
Yeah, hello.
Good morning, sir. I'm Ahmed Mustafa from Nigeria, sir. So from the talks that you have given, I would like to ask some questions. A company like
Yes.
TCS, sorry, am I audible? Okay, thank you. Actually, a company like TCS, it's worldwide known, and I would like to ask, like, do you provide a resume format? Because I know you will be receiving tens and hundreds and thousands of applications, and if you are using the software to fetch out the exact individuals that you want based on some criteria that you want, don't you feel like you are missing out if you are not providing a resume format? Because there are people with high level of experience and they can able to do that job 100%, but unfortunately they did not set their resume based on your algorithm. Please, sir, can you shed a light on that? Thank you.
No, it's not like this is the only thing that is used, but just that if you have lots of resumes, then this system will be used to narrow down on that. But this is not the only channel. So there are other channels also people apply.
Okay, sir. Like, do you mean that after the resumes are being scanned by your system, sorry, by your software, do you manually go back to the resumes once again?
Yeah, it is not like the system is only used. There is also manual check, manual verification always.
Oh, okay. Thank you so much, sir. These are the
Yeah.
questions that I have.
Thank
Thank
you.
you.
Yeah, thank you.
Thank you.
Thank
Any
you,
other
sir.
question, Professor Sachin?
So we are concluding the session. So I'll give to Dr. We can find the vote of thanks.
Thank you, sir, for taking out time and delivering such a wonderful talk. I'm sure the participants over here has gained enough knowledge on this, and even they have understood the way the TCS, you are continuing your research in TCS. Thank you very much, sir.
Yeah, thank you. And thank you especially for Professor
thank
Sachin for giving this opportunity.
Yes, sir.
Professor Sachin, we have a small lab of token of memento and certificate. So I will send through few participants from Pune. So I will be connect with you. So they will deliver
Okay,
at your
yeah,
end.
sure.
Okay. And later thing,
Okay.
rest part I will talk with over telephone. Okay. So thanks a lot
Okay,
for in weekend time. You are given time for morning and you can deliver the lecture. Thank you a lot.
Okay,
Oh,
no
thank you.
problem. Thank you. Thanks a lot. Bye.
So we have another talk. The speaker has joined. You can take a short break. You have a tea and biscuits at the outside, so you can have it. We can quickly join back here within 10 minutes.